Hi class, this video notes is for 5.2 vocab, okay? So the first vocabulary, let's read it together. One-to-one function, super important, okay? A function is one-to-one if any two different inputs in the domain correspond to two different inputs in the range. That is, two inputs in the domain are two different inputs of a function, okay? So these two have to be different inputs of the same function f. Then f is one-to-one if the y values are also different. So let me spell this out. This means when you're putting in two different inputs, y's must also be different, okay? So let's look at a couple of examples. This example over here tells me that this is your domain, okay? Domain means your inputs. This over here is your range, which is your outputs, okay? So, inputs and outputs. Indiana has an output of 6.2 million people. Washington has 6.1, South Dakota has 0.08, North Carolina has 8.3, and Tennessee has 5.8, okay? Now the question is this a function? So is this one a function? Question mark, okay? Well, yes, it's definitely a function, right? A function means each input gets a different output, okay? Gets a unique output. So this one is a function. Now, is this a one-to-one function? Okay, that's another one. Well, a one-to-one function meaning that, hey, not only that each input gets an output, it has to be different. I'm sorry, so let me repeat this. A function is when each input has exactly one output. Okay, so yes, because each input has exactly, well, you know what? I wouldn't say exactly. I would say at most. Okay, I would say has at most one output. Okay, now one-to-one function is when you have unique output. So each input now has a unique output, okay, or a different output, okay? So all of the outputs are different and all of the inputs are different, okay? And that's what it means up here. It said the inputs are different and the output has to be different for it to be a one-to-one. All right, so let's check out this. This one said, you have a set of domains, which is over here, and you have a set of range, okay? So this is range and this is domain. Dog and cats, they both live about 11 years. Ducks, lions, pigs, they live about 10 years. And rabbits, they live about 7 years. The question number one is this a function? Okay, so is this a function? And some of you might say, you know, it's repeating a y value, so it might not be a function. But the answer is yes, it's a function, okay? Because it has an output, because each input does give an output, okay? The question is, hey, because that's what a function is. Each input has at most, that means I don't have to have an output at all, but it has at most one output, okay? Now, it doesn't have to be unique, okay? But it's not a one-to-one, not a one-to-one, right? Not a one-to-one function. Because the output, they're not unique, okay? Look, dog and cat are now having the same output, okay, which is 11, and that 11 is not unique. So what I'm trying to say is that 11 is repeating for both dog and cat. And then in this case, 10 is repeating 3 times, duck, lion, pig. So those two outputs are not unique, okay? They're not different. So therefore, this is not a one-to-one, okay? So that's the definition of a one-to-one function. The inputs have to be different and the output has to be different, okay? Next, horizontal line test theorem. It says, if every horizontal line test intersects, okay, the graph of a function f in at most one point, then f is a one-to-one. So let me remind you what a vertical line test was. Vertical line test, okay, was a test to prove that if it was a function or not, okay, function or not. A horizontal line test is a test to see if this is a one-to-one or not. So there's a difference. Okay, so let's do a vertical line test first, and then you can tell me. Here is a vertical line test. Ooh, okay, anywhere. I can put this line anywhere. Would you agree that doesn't matter where I draw this vertical line test, VL, okay, this is going to be a function, because it intersects only one time, okay? Now, when I draw a horizontal line test, okay, look, this line intersected twice. This line intersected twice, okay? So, this tells me that this is not a one-to-one function, because it doesn't pass my vertical line test, okay? So not one-to-one function. Now we're gonna get down to the definition of an inverse. Suppose f is a one-to-one function. So first we have to identify that f is a one-to-one function. Then to each x in the domain of f, there is exactly one y in the range, okay? So each x has exactly one y. That's what it means. This is just the definition of one-to-one, okay? Because f is a function. And to each y in the range of f, there's exactly one x in the domain, because f is one-to-one. The correspondence from the range of f back to the domain of f is called the inverse function. Okay, so this word, it's kind of confusing. Okay, so what is saying that, hey, for each x in the domain of f, there's one y, and if there's one y in the range, okay, so each y, there's exactly one x, okay, because of the one-to-one definition. The correspondence from the range of f back to the domain of f is called inverse. What this really means is that you are switching, okay? X and y, okay? So if you switch x and y, okay, so the correspondence from the range of f back to the domain of f is called the inverse function. So if x and y are switched, or I should say that, hey, if x in one function is exactly the same as the range in another and vice versa, then those functions are inverses of each other, okay? Like this one. So look at this dot, okay? See how this dot says that the input is B and the output is A, but this dot right here is switched, how x and y are now switched. Now the input is A and this dot is B. So these two dots are inverses, okay? These two dots are inverses. Okay, graphing inverse functions theorem. The graph of a function f and the graph of its inverse. Okay, so now notation. Its inverse of f is now used with the f to the -1 power. So I just want you to make sure that when you see this, this means an inverse function of f, okay? Are symmetric with respect to the line y equals x. So check this out. See this line right here? Y equals x is this line. See this? That's the line y equals x, okay? That means if x is 1, y is 1. If x is 2, y is 2. They are exactly the same. If x is -1, y is -1. They are symmetrical, meaning that here's my original, here's an f, okay? Here's its inverse. They are reflected over this line. So if you see, or if you are provided with two graphs and they are reflected over this line, then that means the two graphs or the two functions are inverses of each other. Okay, so this is our example 1. Let's read the directions first. Example 1, determine whether the function is 1-to-1. Okay, so let's check this out. A, they gave you, for the following function, the domain represents the age of 5 males and the range represents their good cholesterol, HDL, okay, of the 5 guys here. So let's check it out. 38 has a 57, that's a different output. 43, 46, 55, 61. So the x's are all different, okay? All different. If I can spell different. Okay. Now let's check out the y. Well, 42 has an output of 54, or this guy at age 42 has a good cholesterol of 54. 46 has an output of 34. Okay, even though these x's are different, look at this y value. Is that y value unique? Okay, that means, hey, this has a 38, that means this has a 38, so this is not unique. So it's not unique, so therefore we can say that this is not a 1-to-1 function. Okay. All right, so this is where we will stop. Have a wonderful night.